Assalamu alaikum kids, this is Ayaz again, and I'm going to teach you math 7. It's going to be your lecture 5 now, week 2 lecture 5. The last day, basically this is the lecture 5 of your this series, and the topic was other forms of direct proportion. So I basically dedicated this lecture for the kind of revision what have we done over here. In fact, I will try to cover it up, this topic and the previous one, just the recaps of all those things. So here basically we have already now comprehended this topic. The concept was the direct proportion, and it's basically a relationship between two or more quantities basically. And this relationship, how it goes is, if one of the quantities is going to increase, the other will also increase, and the same way if one of the quantities is going to decrease, the other will also decrease, and this increase or decrease has to be in proportion. And as I've already told you, this is mathematically, we can write it down as is in front of you here. Y1 over x1, y2 over x2. The first equation is basically the two rates are equal, as I told you already. Or you just play with this the same equation, you can rearrange that equation, you come up with the second one equation over here, x2 over x1, y2 over y1. The second one is basically the ratios. You remember, the ratios are between two quantities of the same kind, x2 and x1. They are of the same kind, and the two ratios are equal. So in proportion, direct proportion, either rates can be written as they are equal, or the ratios are equal. And we can draw the same relationship, direct proportionality, on the graph paper also. And when the two quantities are in a direct proportion relationship, the graph is always going to be a straight line passing through the origin. That must be there. And this is kind of graphically, when we see a curve over there, and we can decide whether this graph represents a direct proportion or not. And here let's start recapping the things. Before the other forms of direct proportion, you have already studied what is basically direct proportionality. So mathematically you could see, when we say y is directly proportional to x, that's how we write it down. The symbol is in front of you over there. When you remove the sign of proportionality, you have to introduce an equal sign. And when you put the equal sign over there, you have to put over there the constant of proportionality. Only then you can equate left and right side. Means when you remove the sign of proportionality with the equal sign, you have to introduce a constant of proportionality, and you can write it down and denote it with any letters. Here we used to do it with k. So y is equal to kx here, and then you can see the k is equal to y over x. X is multiplied on the right side, it goes to the left side, and it will be in the denominator. So what does it mean when we say, means the ratios must be the same for all values of y and x. So if the two quantities are there, means you can take many values of the one quantity and the many values, corresponding values of the other quantity. So you can come up with the ratios, and for direct proportionality the ratios must be same. And let me demonstrate in front of you. So I just took two values of the quantity x as x1 and x2, and their corresponding values of y, I took it as y1 and y2. And from the first pair, x1 and y1, because the corresponding values of x1 is y1, so direct proportionality means y1 over x1 is going to a constant k. Yes, okay, let's call it as equation 1. And let's take now the second pair of values, x2 and y2. I mean the corresponding values of x2 is y2. And you could see, because x and y are direct proportional, so we can write it down again. Y2 or x2 is equal to k again, constant same. Remember, for all values of the two quantities, the ratio must be equal to the same constant. So you keep on taking different values of the two quantities. They're all of their ratios are going to be same constant k. If you want to call it as k, you can call it as any other alphabet over there. So equation 1 or equation 2, you can write it down. Since the right sides of both the equations is equal to the same number k, so that definitely left side is also both the equations are going to be equal, have to be equal. So as in front of you over there, y1 over x1 is equal to y2 over x2. So this is kind of representation of rates. Remember, rates is between two quantities of different kinds. So you see, y1 over x1, different kinds. So these left and right sides representing the two rates, and they're equal. Same way, I mean, just to manipulate this one, I mean, take the x2 on the left side, it's divided on the right side, it goes to the left side, it comes on the up in the numerator, and you see x2 over x1, y2 over y1. Now both of them represents the same direct proportion. So in the last one, you see the ratios are equal. So that's how you come up with that. I told you over there in the summary, this relation, how you derive this relation. And when you have basically two quantities that are directly proportional, as I said, they are always going to represent a straight line, and that straight line have to pass through the origin. A straight line passing through other than the origin, it's not going to be a direct proportion. It has to pass through the origin. Remember, what is the origin? Origin is basically two perpendicular lines intersecting at a point. You have already seen that Cartesian plane over there. Now, as I said, we have done one of the word problem over there, in which the length of a simple pendulum was directly proportional to the square root or a square of its period, which is represented by t. So in that case, the relationship is going to be L is equal to kt square. So here in this relationship, if you draw the graph between L and t square, that is going to be a straight line passing through the origin. But if you draw the graph between L and t, not t square, so that is not going to be a straight line. So graphically, when you see the graph, you can things. Take another example over there. This is one of the examples, word examples in your book, in which the volume V, and you remember volume is basically measured in centimeter cube, cubic centimeters. You've already studied in previous classes. So volume V is directly proportional to the cube of its radius. When you have a cube and its radius is r, so this relationship is going to be represented as V is equal to kr cube. Okay. And in here again, if you draw the graph between V and R cube, you will come up with a straight line passing through the origin. But if you draw the graph between V and R, that is going to be not a straight line. So these two examples are of other forms of. Okay, champs, it's time. I hope you have already comprehended the topic now. It's time for the evaluation. So let's take a small test here. So champs, get ready. You can write it down, the questions, and take your time to solve it. Here's your first question. Question number 1, basically you had already one complete pair, 5 and 6, 5 and 2, and you can use that pair to find the constant of proportionality, and then of course you have to find the value of y when x is equal to 7. And the question number 2, of course, is about the other forms of direct proportion. There are 3 parts over there, so you're gonna state which 2 variables are directly proportional. So you can solve this question is based basically, which you have done a question in the exercise. It's almost the same way. And the question number 3 here basically is between two variables that are directly proportional, and it's under P and Q. And the complete pair is there, 21 and 9. Use that one to find the value of K, and then find the value of Q when P is 81. So that's it for today. Solve this, try to solve these questions, don't be scared, and then send back to me your responses. I'm waiting for your responses. Thank you.